everyone. Welcome to Batch Working Group updates. My name is Marcin Wielgus. I'm one of the organizers of this working group. So you all gathered here, so you probably have some intuition what Batch Working Group is all about. My laptop almost died. Okay, so Batch Working Group is a forum to discuss enhancements to better support batch workloads in Kubernetes. And by batch workload, I mean everything that is related to high-performance computing, AI, machine learning, data analytics, continuous integrations. And the goal of this group is to reduce fragmentation in Kubernetes ecosystem. People in Batch Working Group come from different SIGs. We come from SIG scheduling, SIG apps, SIG nodes, SIG autoscaling, and we definitely can operate with the SIGs, but we are not limited to the SIGs. We also have some people who are just coming to this group from outside. The scope of the group is to talk and discuss and do additions to batch-related APIs, think about job queuing and scheduling primitives, do tools that maximize cluster utilization, and make the best use of the hardware to improve the workload performance. And we also work on supporting specialized hardware for batch, AI, ML, and all that sort of stuff. How to take part? Probably the most important part of Batch Working Group is our Slack channel. We have bi-weekly meetings. They are both in European time friendly slot and in West Coast Pacific time slot. The details you can find in the link below, along with calendar invites, Zoom links, and all of this stuff needed for you to join these meetings. What is Batch Working Group doing? Probably our biggest endeavor and biggest project is Kueue. You might have heard of Kueue, but for those who have not so far, let me give you a little bit of introduction of what is it. So Kueue acts a little bit like a bouncer in a club. He decides who should wait, who can get in, so that the club is not too crowded. And by club, I mean Kubernetes cluster. It acts a little bit like a receptionist desks who admit people with pro-reservation quickly and let other waits. It also acts like a little bit of a waiter in the restaurant, which gives you the table and takes you to the desired seating. And when we're talking about people, we are actually talking about various computational units that come to the cluster. And this can be in form of Ray job, it can be plain pods, it can be classic, pure vanilla Kubernetes jobs, or something from Kubeflow portfolio. In Kueue and in the remaining of this presentation, we will refer to all of these things as workloads. Okay, so that was a little bit of introduction. Let's get a little bit more formal. So what is Kueue? Kueue is AI HPC batch workload level scheduler. And by workload level scheduler, I mean that it operates on workloads, see that as a whole, not on individual pods like, for example, Kueue scheduler. It determines when to start, stop, or preempt a workload. It supports all or nothing, also called as gang scheduling semantics. So when deciding when to start and stop, it assumes that the whole thing should start, not only a fraction of it. It is very critical for machine learning stuff because these things require all pods and all pieces of computations to be present in order to make progress. And Kueue decides where in the cluster should it be running. Should it be running on that specific machines, maybe with these accelerators, maybe on spot, maybe on demands, maybe on your reservation, maybe in a specific rack, or maybe in specific nodes. All of these things could be decided by Kueue. Kueue is also a resource quota manager. So it allows you to provide quotas to multiple tenants and define quotas on various levels, on various types of hardware, or also other type of resources that you may want to utilize in your cluster. It has built-in integration for various APIs. For classical things from training and batch world, like Kubernetes jobs, JobSet, Kubeflow portfolio, Kueue, as well as for inference/serving, deployment, stateful set, leader worker set, and other things that could be used universally, like a wrapper, plain pods, and pod groups. It is hardware, vendor, and cloud provider neutral. It means that it works with GPUs, TPUs, or whatever custom hardware you may have on any cloud that you may be running, and also on-prem. So what is going in Kueue? Kueue has been around for quite a while. It would be probably like 3 years or so. And during that time, we have had about 50 releases. The most recent one happened a week ago. So this is a very, very active project with new good stuff constantly coming in. During this presentation, I will bring two things to your attention that came recently. These are topology-aware scheduling, file sharing, and hierarchical quotas and resource controls. Let's start with topology-aware scheduling. So imagine that you have a data center, and in this data center you have a couple computers connected to one switch and a couple computers connected to the other switch, and there is a connection between these switches. If you put your workloads kind of randomly, you may get quite decent utilization. Here on the picture, you see that all computers are pretty well utilized. Each of them is running 4 pods from different applications. Utilization is 100%. And, well, this seems ideal, is it? Well, not really. So here on this picture, we have 3 workloads, pink, green, and blue one. As you can see, pink is located more on the right, but it also has some pods on the left side. The same applies to green workload and the blue workload. If these workloads are doing just computation, the situation is okay. But if pods from each of the workloads require to talk to each other, then this link between the switches becomes a bottleneck. Purple pods from the right want to talk to purple pods from the left, green from the right to the left, and so on and so on. It becomes congested, and none of this workload is performing well because all of them are fighting for this red cable in the middle. The cable is on fire, the workloads are not performing, GPUs that are super expensive are effectively wasted, everyone is unhappy, and that's obviously a bad situation. With Kueue, you can arrange these things a little bit better. For example, put all of the pink pods on the right-hand side, and blue and green on the other side, and then they are doing only internal communication, which doesn't put too much load on this middle cable in the picture and linking the switches. And that brings a lot of peace of mind to both system administrators, cluster owners, and ML researchers because their workloads are progressing well and GPUs are well utilized. The other thing that we have in Kueue is file sharing. So imagine that we have a large data center and 3 teams of researchers. The blue one, the red one, and the yellow one. Based on their size, their priorities, the importance of the project, some director divided the cluster into fragments and assigned a quota or capacity to each of the teams. The blue team got 3 racks, the red team got 7 racks, and the yellow one, the remaining 5 racks of GPU-intensive, GPU-heavy computers. All of them are using it to the large extent, but sometimes holiday occurs, sometimes offsite, sometimes people have summits, and sometimes not all the capacity is utilized to its fullness. So what happens then? Obviously, we don't want to waste the resources that were previously assigned to the red team while they are playing volleyball at Hawaii. We don't also want these resources to be given to one of the teams based on their time zone because they arrived to the work earlier or they have some other way of getting these resources between the yellow team. Ideally, we would like to have a mechanism to split the unused resources in a kind of fair way, so that neither blue team nor yellow team complains, and the capacity of the cluster is well utilized and money well spent. And of course, when the red team is back from their offsite, holidays, whatever, they are fully entitled to reclaim their capacity and use what's theirs. Okay, so in Kueue, we have two flavors of preemptions. One is preemption-based. So imagine that if blue team is using too much of the shared resources than the yellow team, and yellow team wants to run a smaller workloads, and there is no space left, then blue team should have some of their workloads preempted. Let's look what does it look like on an example. So here we have some shared capacity. Let's assume that it consists of 100 GPUs, and blue team has 3 workloads, 50, 30, and 15 GPUs each. And yellow team wants to run a relatively small workloads, which consists of, which requires 20 GPUs. Obviously, there is no space, but blue team is kind of abusing its fair share. It's using more than it should. So if we use this form of preemptions, this form of fair sharing, we preempt one of the workloads from the blue team in order to make space for workloads from the yellow team. Now the division and fair sharing of the sharing of the unused capacity is a little bit more fair. What happens if yellow team wants to submit yet another workload? This time that requires 35 GPUs. Well, blue team is still using more GPUs than the yellow, but if we preempted some workloads on the blue team, then the situation would reverse, and yellow team would get much more than the blue one. So we don't do it. We keep these other workloads waiting. So that was one form of fair sharing that we have. The other form of fair sharing that is coming really, really soon to Kueue, it's called coded and will come with the next release, is admission-based fair sharing. Previously, we were preempting workloads of the other team if they were using more of this shared capacity than they should. This time, we do it differently. We wait. So if blue team use significantly more resources than the red team, workloads from the red or yellow team should be given preference for the upcoming admission. So here, the workload is coming, and it's waiting. And it's waiting until something from the blue team is completed, and then it's submitted. If something more from the blue team is submitted, it waits, because the blue team use more of their capacity. And then we admit something from yellow team because yellow team use more. I now notice that I have a mistake on the slides. There obviously should be yellow team in the text. Sorry for that. Okay, one last thing that I would like to discuss is hierarchical resources. So with this quota thing, organizations want to kind of divide quota in the way they are structurally organized. So director gets some quota, then this quota is distributed among its managers, and then managers give this quota to individual teams. This is something that you can configure for Kueue. You can have hierarchical quota that follows your org chart, and also all of the fair sharing that I previously mentioned also follow the org chart. And company politics. Manager probably wants to distribute unused capacity from one team among their other teams. The same applies directors and so on. They want to distribute unused capacity among their people, and then if the needs of their people are satisfied, the unused capacity goes to the rest of the company. Okay, so these were three things that we have launched or we are launching right now. What is coming soon? Basically, we are doing more topology our scheduling in topology our scheduling. We want to include more pieces of Kubernetes scheduler code in Kueue so that the admissions and positioning of the and placement of the pods is more precise. We would like to give more controls for scoring topologies and influencing the decisions of Kueue in terms of which rack and which workloads are placed together, and handle recovery and errors better. We want to expand admission-based fair sharing to all hierarchy levels and do some significant improvements to multi-Kueue. Multi-Kueue was launched more than half a year ago. Is Kueue's attempt to handle multicluster job distribution. It is getting some adoptions, and we received a lot of feedback from the customers and users. And based on this feedback, we want to improve controls over which workload goes to what cluster, and support bare pods, and nice things for researchers like getting logs, executing things in the containers, and so on. Okay. The other project that batch working group is working is kubectl, which is basically a tool to perform day-to-day operations on Kueue, like creating queues, draining queues, stopping and starting queues, listing workloads, along with their position in the queue, pausing workloads, and all of the stuff that you may imagine that you may encounter in your daily work as a batch cluster administrator. It comes as a kubectl plugin. It's managed by Kueue. It's already launched, been around for a while. It's relatively stable, so if you're using Kueue, you probably should take a look. Okay, and then we go to APIs. Job. Job has been in Kubernetes for a very, very long time, probably from 1.0 or 1.1 release, and it's really, really mature Kubernetes API. Most features are already in, however, some of the features are still coming. In particular, we are graduating a couple of things, like managed by field went to beta in Kubernetes 1.32, pod failure policy went to GA in 31, success policy will go to GA in 33, and backoff limit per index will go to GA also in 1.33. JobSet. You may think about JobSet as Job API on steroid. It's an API for managing groups of jobs as a unit. It offers a unified API for deploying HPC and AI ML workloads. It comes with extended policies around starting, stopping, discovering failures, discovering success, restarts, and all of the things that you may want to configure for your jobs. It allows you to run multiple jobs connected to each other as a single unit, and gives you like a nice service to govern them all. The API is also relatively stable and mature, and is getting adopted by both users and frameworks. For example, Kubeflow Trainer v2 is built around JobSet API, and Metaflow is using JobSet for their distributed training. So again, individual users are using it, companies are using it, frameworks are happy with it. So probably, if you are not using JobSet, you may want to take a look at it. Last thing that I would like to talk about today is Kueue. And Kueue problem statement is around this. So how to start lots of one-time jobs that have complex storage setup. So it consumes input, produce output, has some logs, binaries located in various places, maybe on NFS, maybe on S3, maybe on GCS, all things around. So they have like really complex configuration around volumes. And these jobs differ very little from each other. They maybe have a little bit different arguments for the scripts, maybe the different image, maybe slightly different input files, but overall these jobs look the same. They basically like coming from researchers, and their daily work. And these researchers would like to start them via command line tool. They, for example, come from Slurm world, and they are really used to start playing with command lines instead of editing YAMLs. And all of these jobs are not started by a single individual, but are constantly used by entire team. So Kueue is our way to address it. It's a set of reusable job templates stored in API server with a command line interfaces that transform these templates into full YAMLs and send back to API server for execution. Okay, because they are stored on API server, they can be reused by team members. They have some fields in the template already populated, and some of the fields are intentionally left blank for the researchers to fill. Each of this template has information which parameters need to be provided so that it is complete and can be executed. And these templates cover job, JobSet, Kubeflow jobs, and standalone pods. So the flow with this tool looks like this. The admin creates the templates, sets all of the storage, volumes, mounting points, and so on, so that when researchers come, they just need to select the template from the list, provide additional flag like the script name, or maybe parameters, or model name, or whatever, and then this template is compiled into fully baked complete job and submitted for execution. I mentioned Slurm a moment ago, so one of the reasons why we did this is to make users coming from Slurm a little bit easier. So in Kueue there is a special mode with, which tries to provide Slurm-like experience. It is script-centric. It provides users with familiar command line options that mimic one-to-one those that you can pass to srun, maybe. It has same environment variables built in. Slurm scripts, when executed on Slurm cluster, get quite long list of metadata information like the index of the task and other things as environment variables, so we mimic them, and we offer a similar approach to shared storage binaries, input and outputs. And this thing is aimed on making migrations between Slurm and Kubernetes a little bit easier. Okay, so as you might have noticed, we are trying to provide a kind of batch ecosystem with Kubernetes as a foundation. Then we have Kueue, which manages job execution, quota control, scheduling, and all of the nice things related to execution. And on top of that, we have a set of APIs and command line tools. Command line tool for playing with Kueue and APIs for running jobs. And on top of that, K-jobs to make running these APIs a little bit easier. This is just a suggestion. You are free to extend it, use whatever components of this proposed ecosystem as you like fit. And if you have strong opinions, what is missing, what should be done completely differently, where we are wrong, please come to batch working group. Let us know what you think, what's your opinion, what are your needs, and we would be very, very happy to listen to your feedback. Okay, I guess I have a couple minutes for questions. The mic is here in the middle of the room. Please come.
Thanks for the presentation. Question for the fare scheduling. Is it that the quota is just the current quota of, or the current distribution of jobs? It's not historic CPU hours that are consumed? So if like someone, like the blue team runs jobs for a whole day and then the red team comes in and wants to run a job, but at the current state, the proportion of distribution is okay, then like taking vCPU hours into account and not just the vCPU used at the current state?
So you're talking about fare sharing?
Yes.
So we have two flavors of fare sharing. One with preemptions, which doesn't look at the historical data, and the other one, which is admission-based fare sharing, and it stores like a historical usage. It's basically like decaying aggregated usage over some period of time. So we accumulate how much of the shared capacity a team used, and based on the shared usage, with some weighting applied, if you provide the weights, we sort the workloads and admit them according to this workload. So the team that use the shared capacity the least, with the weight combined, got precedence over teams that used more in the past. Of course, if only one team has workloads, we don't stop them from sending them. But as soon as some other team comes in and they haven't been using the shared capacity for a long, they get like the first spot on the line.
But you don't preempt based on the historic
In that
use.
mode, we don't preempt it.
Yeah.
If you want preemptions, then we have a mode in which preemptions are applied.
Okay, cool. Thanks.
Hello, I have some question. On the ecosystem diagram, there is a field of other CRDs. I wonder how does, for example, Argo workflow fit in?
Into other CRDs. So Argo workload, as far as I remember, is integrated with Kueue, or? Yeah, Michał? Have we merged it? Okay, so we have a way of using Argo workloads with Kueue. I think that there is some documentation on the Kueue site. It was merged like really recently.
Right, so Argo workflow is on top of the Kueue.
Yes, it's probably yellow one, other CRDs that can use Kueue to queue its individual steps.
I see. Thank you. And my second question is, for the HPC type of workflow, for example, we have simulation work that we want to do. Each work does not take very long per se, like maybe 2 to 3 minutes generate a geometry. And they usually use like CAE, these like Windows-based software. And I wonder, for a use case where user would submit like hundreds of thousands of very short running these simulation work, how can one leverage this ecosystem to do?
So Kueue can handle quite a big traffic. And we run tests with workloads coming at a really, really big speed. And the limitation factor is not Kueue itself, but etcd and whether your cluster and API server can handle the amount of updates happening to pods, jobs, and so on.
What do you mean by the updates?
Okay, so when you start a job, let's assume that it has 10 pods, okay? Each of the pod needs to be created once the job is started. And
Yes.
once you create a pod, it's an API server write. Then you need to schedule each of these 10 pods on some nodes, another set of writes. When these pods land on nodes, again, they need their status, they need to have their status updated, and again, another flow of writes to API server, and so on and so on. So the limiting factor for large flow of job is the performance of your control plane. So whether it can handle this amount of churn in the cluster, the amount of pods being created, updated, scheduled, and so on. And not necessarily like you. So if you think that you have good enough control plane, then Kueue probably wouldn't be a bottleneck there.
I see. In that case, when we fire some job, the pods needs to be starting up, but usually the image for simulation type of software is quite big, and then the starting time would be quite a lot. So I wonder if using this ecosystem, is it possible that we have a pod that's always there, waiting for the job requests, but then it also sounds like it's
yes,
bypassing.
you can have it. It basically means that you're doing it like a batch serving. So you have a service that gets requests and you respond to the request. So if on the slides I described that we support serving API. So you can deploy this thing that does this relatively short processing as a deployment or leader worker set or whatever fits your architecture the best. And then it sits there and process requests that are coming. Or you may back it up by message queue, put things on the message queue and start and stop pods as the things arrive on this message queue. However, for very short computations lasting a minute or so, probably it's better to set up a long-lived service instead of starting and stopping pod constantly.
Right. So this setup is more suitable for very long running job and a batch long running job.
I would say differently. On this diagram, you don't say deployment, but you can imagine that we add yet another yellow rectangle there, put deployment label on top of it, and then this diagram will suit better to what you are describing. So really, really short computations happening in great quantity.
Right. The deployment would be on top of the queue?
Sorry?
The deployment, where would the deployment?
It depends how you position this service. Is it like a service for some computation? I don't know, you do weather forecasting, you do this computation for 2 hours and then you go away? Or you need it to be running 24/7? Okay, I'm running out of time. Sorry. We can talk about this use case in the lobby.
Yes.
If no, okay?
Thank you.
Thank you. Do we have time for one more question? Gone.